Welcome back all of you. I'm Anshul and we'll previously discussing about the experimental setup for the course experiment in fluid mechanics. So in the previous lecture we studied about low speed wind tunnels or basically subsonic wind tunnels, and now we'll be studying about the high speed wind tunnel. Now how does it matter compressible and incompressible? It will matter in some other ways when we'll make the measurements, as we'll be seeing later on. So as far as the high speed wind tunnels are concerned, the first one of them is transonic wind tunnel. As you all know, transonic means where some of the portion of the flow is supersonic and somewhere it is subsonic. So what are the special issues that are associated with transonic wind tunnel? So there are two peculiar problems that come with transonic wind tunnel, and actually transonic wind tunnel were so difficult to develop that they were developed even after supersonic. So what are they? So first of all is the reflection of shock. So why so? Because you can see, you know that when the Mach number is relatively less, say 1.1 or something, so the shock angle that will be formed by oblique shock, that shock angle will be large. And when it will be large, when it will be reflected from the wind tunnel walls, there is a possibility that it can hit back again on the object, which will create to deviation of the flow. So what to do? We have to keep the object size small within the shock rhombus. That is a problem. Another main problem is that due to this presence of object in the test section, the flow can itself become choked. Before it gets choked in the nozzle, it can get choked in the test section. If it gets choked there, the free stream will never become supersonic. So these are the two pertinent problems, and guess what is the solution? So there is a single solution that solves both of them. That is the use of perforated or slotted walls. So by that, the shocks usually go out rather than being reflected back, and that also helps avoids the flow being choked in the test section. So this is particularly about the transonic wind tunnel. The components remaining almost the same. Next we will talk about so this is in brief. Next we will talk about supersonic wind tunnel. So supersonic wind tunnel, as you know, the flow is supersonic or the free stream Mach number is greater than 1.2. So they require enormous amount of power to run. And usually this supersonic wind tunnels, they can be classified as continuous or intermittent. Continuous means which are running continuously for a sustained amount of time, and intermittent which will run only for a short duration of time. The intermittent can further be classified as blowdown type and suction type. So the blowdown type, there is a compressor and there is compressed air coming from a pressurized chamber. In case of induction type, there is a vacuum chamber and air is sucked in. On the other hand, in continuous, there is a continuously running wind tunnel. From the there is continuous operation of the wind tunnel requiring very high power. So the relative advantages and disadvantages already been provided to you, and some of the numericals have also been discussed. But in brief, each of these, whether the suction type, in suction type or the induction type wind tunnel, we are sucking air from the atmosphere. So the properties remains fairly constant but are not in our control. In this blowdown type coming from pressurized tank, the flow properties change with time after some period of time, and they can be controlled better. The detailed diagrams are already been given to you, and some numericals have also been provided in the class. So the advantage of this intermittent is they require less power, they can be charged over some time, and the continuous is advantageous because it can be run for longer duration, but it requires very high power. Also the Mach number that can be achieved in blowdown is much higher compared to compared to continuous, and further details we will be studying later on. Then the hypersonic wind tunnel. Hypersonic are very less used. They are extremely less used, and they are required in special purposes like missiles, rockets, etc. And it is very difficult to obtain free stream Mach number above 5. So what we'll be doing in that case is that the test section is usually kept small. In order to so that the power requirement is within some limits, the test section is kept small. So that is actually the only way to sustain. Still, it requires tremendous power and is used. There is some other similarity parameter that is used in case of hypersonic similarity parameter, but we won't be talking in much details. But that is m infinity times theta, where theta is the angle of curvature at that point. So this is a brief introduction to different type of experimental setups, wind tunnels. And other than this, there are the water tunnels and the towing tank. So more details about the water tunnel and the towing tank that we'll be covering in the next lecture. This is briefly about the high-speed wind tunnels. We'll also be talking about different type of measurement techniques in the following lectures.